Okay, so let's just finish this up. I found out my problem. So the problem was that I was trying to find this vector v which satisfied equation 3. And I was trying to do that by writing out v in terms of x and y and z components. And then I got to these equations 1, 2, and 3. And I was trying to find the most general solution to these equations. And I was kind of just getting lost. And it was frustrating. So actually though, just after I made this first video, I thought about it and I realized a nice little, I realized that there's a very easy way to do this. Not very easy, but just more simpler. So I'm debating on whether or not erasing all of this stuff, which I think I am going to erase all of this, but it's not super important. It's taking a while. I want to select all of it, not just one thing. Oh gosh, this is annoying. Okay, did you delete? Delete, please. It's going to delete. It's not going to delete. Oh my lord, this is taking forever. Come on. Very, very frustrating. Okay, now delete. Why is it so slow? Oi, 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 oi. What is this? Okay. I'm kind of starting to feel like because this is not working that I should maybe keep things the way they are. Maybe there's a reason. Okay, but this is like so slow. Every time I do something, it's super slow. Okay, whatever. Instead of trying to erase it all, so this is a simpler argument. Okay, so going back to this equation, curl of v is equal to alpha z at. So let me just draw it again. some surface S, this is my Z, X and Y. Okay, and V is some vector. V is a vector. V V is some vector. Oh, so V is defined okay, so V okay. So you have a vector at each, so this vector depends on X, Y, and Z. So I choose an X, Y, and Z. So each point on the surface, this is the vector rho. Mm-hmm. Yes, and then I also have this vector Z hat, which is my normal. Okay. But, okay, now I'm going to call this equation 1. I'm going to mess everything up, but so 1 is also satisfied with a new vector v prime, which is equal to v plus the gradient of some scalar function. It depends on x, y, and z. And this is because the curl of v prime will be the curl of v plus the curl of the gradient of phi. And this is always equal to 0. So it's just equal to alpha z hat. So by shifting the vector by this scalar function, or the gradient of the scalar function, we still obey equation 1. So V is not, that's supposed to be not a unique solution. So we can choose any phi, and it has is a valid solution. Okay, let's go one step forward. So recall, we'll call it equation 2. The area is equal to 1 over alpha, the integral from 0 to 2 pi of dt v dot d rho by dt. Okay? And then we should, so basically the area should not depend on this choice of v. So we should get, I don't know why it's being so effing slow. Same area. Why is it so slow? If we use v prime instead. Okay, so the area should not depend on this v. Right, the area should only depend on the path we walk. It shouldn't depend on this vector field that I'm not even sure what it physically means. So that means that if I have this new area, A prime, that has to equal A, right? Maybe I should write that the other way. So the area is also equal to A prime. A prime is equal to 1 over alpha integral of 0 to 2 pi dt of, still have this part, ed over dt, but now we have to add to this the gradient of phi Okay. Okay, but this gives me A plus 1 over A alpha integral from 0 to 2 pi dt gradient of phi dot d rho over dt. Which means, so therefore, the integral from 0 to 2 pi dt, the gradient of phi dotted into d rho by dt, this has to be equal to 0. So to show this, so see that this is true. Note, okay, so if I do d phi, well, phi is a function of x, y, and z. So this will be d phi over dx plus d phi over dy times dy plus d phi over dz. Okay, but if I divide by dt, and I note that dz by dt is 0, well, this is the same as the gradient of phi dot d rho by dt. Therefore, I'll call this 3. 3 is the same thing as, if I integrate both sides, right? So this has to be equal to 0. From this relationship here, I plug that into here, I get this. So that means that phi at t equals to 2 pi has to be equal to phi at t equal to 0. Right, which is true because this just means x at 2 pi, so on, has to be equal to phi at x at 0, and so on. Which is always true because x at 2 pi is equal to x at 0 because you have a closed curve. Okay, so what this tells us is that for any choice of phi, when we integrate that, so this phi of x, y, z, when we integrate around the boundary, it will become, we'll use this function instead because x, y, and z are parameterized by t. And we integrate that around the boundary, we will get 0. For any choice of phi, when we integrate this around the boundary, we will get 0. So for any choice of phi, then all we have to do is find a v which satisfies curl of v equal to alpha z hat. And gives area A. Then we can construct any other vector v prime equals v plus the gradient of phi, and still get the same area A. So that's kind of important. So really all we have to do is, so note, all we need to do is find the simplest v. We don't have to make our life hard. So we don't have to find the most general v, because we know that we can always make v as complicated as we want, and the simplest v and the most complicated v give the same area. So we're free to just use the simplest one. Right, because I'm adding on to v any other function, really. Just I'm adding on to v some general function of x, y, and z. So I can make that whatever I want. And it will always satisfy this integral equation 3 because on boundary, this is always true on the boundary. Yeah. So recall we had this first equation, which was dg over dx minus df dy is equal to alpha. The second equation, I forget, which was, things really got messed up here. Dh over dx is equal to dg over dz. Dh over dx is equal to d g over dz, and the third one, which was dh over dy is equal to dgf dz. Okay, so since we want to find the simplest v, so we're just going to let h equal to 0. I'm not going to bother with any of that. I'll write it over here. So let h equal 0. Then okay, and then dg over dz, and g is a function of x and y, and f is only a function of x and y. Make our life simpler. So this is simple. Okay. Yes. So then we're gonna say we're gonna let g of x, y be equal to alpha cosh squared phi times x right? We don't even need a y, right? Yeah, we don't even need a y. And f of y okay, so then this equation is satisfied. All right, so then it's super simple. Then my vector so then v is, okay, I have an alpha out front, and it's just a cosh squared phi y. Oops, I messed it up. Oh, I should probably change notation. Call it theta, I guess. Okay. All right. So then my area becomes, well, 1 over alpha cancels with this alpha, so it becomes the integral over dt from 0 to 2 pi of yeah, theta and alpha don't depend on t. Yes, and also this integral should not depend on theta. Okay, so there's two ways. Well, I mean, I see two ways to kind of go about doing this. So the first way is to say that dA over d theta, so this has to be equal to 0. Right, and so I did the derivative of these things, so that just means that I'm going to get a sinh theta cosh theta times an integral from 0 to 2 pi right, but this cannot be 0 because it's an area. Therefore, theta has to be equal to 0 so that the sinh of theta is 0. Those two things are the same, right? Yes. So in this case, we have that A is equal to the integral of x y dot. Okay, so that's the first way. The second way is to say, hey, well, what actually is this integral from 0 to 2 pi dt times y x dot? Okay, well, this is equal to, I'm just using integration by parts. So it's xy at 0 to pi minus the integral from 0 to pi v du, so my v is x, my du is y dot times dt. So this part gives me 0 because x at 2 pi is the same as x at 0, same as y. So this is just equal to minus the integral of dt x y dot 0 to 2 pi. So now when we go back up into our area integral, we see that we can replace this first integral by the negative of the second. So then my area is then equal to, I'll just factor out this integral that's common of x y dot. And we're left with the cosh squared theta minus sinh squared theta. And this is equal to 1. So we just get that area is the same thing as before. 0 to 2 pi dt x y dot. So what this means is that we can either choose well, what it means we can choose whatever value we want for theta. Yes, that's what it means. It could have went the other way though, right? Could have also said that area is equal to the integral from 0 to 2 pi, and I could have taken the other one, dt y x dot. And then in that case, I would have seen a minus sign. Which means that area is equal to minus the integral from 0 to 2 pi. But the point is that the area is equal to the integral from 0 to 2 pi dt x y dot. Okay, so then, yeah. Now we're going to say, let's take phi to be equal to of x, y, z. Let's just make something up. We'll have 1/2 x squared plus 2yz, whatever. So the gradient of phi is equal to x 2z and 2y. That's a y. Okay, so my v prime is equal to my original v, which is alpha, and then this was the sinh squared phi, and for sinh squared I'm going to use s squared y cosh squared x. Oh, I have to add on, so I have to do, this is plus x cosh squared x plus 2z. We have 0 plus 2y. Okay. And what do I want to show? So first, I want to show that the curl of v prime is equal to alpha z hat. Oh, crap, I messed up. There should be a nabla x, nabla y, nabla z. Okay. Alright, so that means that for the z hat at least, we have nabla x, so we just get cosh squared minus sinh squared and the z hat, which is equal to alpha z hat. Check. And we have to have 0 in the other dimensions, which we do have because we have 2 minus 2, and here we have, so that was in the y, in the x, and sorry, that was in the x. In the y direction we have 0, 0. Good. Now we have to check that the integral from 0 to 2 pi of dt phi dot d rho by dt. We have to check that this is equal to 0. So this should be equal to 0. So we'll get the integral of dt 0 to pi times this stuff, which is x dot plus 2z y dot plus 2y z dot. I wonder if there's, like, I can do integration by parts on each of these. Well, first of all, we know that this is equal to 0. Question is whether or not this part equals 0. So, okay, so my first integral, integrating by parts, okay. So v is x du. So it's just the negative of the integral. This one, I get v u, and then a minus 2 integral of v du, which is just a y z dot. Okay, so this doesn't look promising, does it? Okay, so there's a bug. There's something went wrong. Something here went wrong. Okay, let's see what happened. So let's say if I write d phi. This is d phi by dx, which is 1. Oh, sorry. D phi by dx is x, right? X times dx plus 2z dy plus 2y dz. Okay, then d phi by dt. And this goes away. Yeah, and this is the gradient times. So this has to be equal to 0. I'm unable to show it for some reason. Yeah, so I mean, this is true. So this integral has to equal 0. I just don't see it right now. Oh, this z dot is equal to 0. If we have the integral of this has to be equal to the negative itself, it has to be equal to 0. So this must be equal to 0 because this Because essentially we have the integral of dt x dot is equal to negative the integral of dt x dot. So therefore, it has to equal to 0. Okay, so it works. So my question is, what is I don't think it has any physical, there's no physical right, because v doesn't change the area. Phi does not change area. So if I change phi, it doesn't change the area. But if v goes into Stokes, with ds equal to z hat dA, then the area of the surface is calculated. Calculated. So v is the vector that gives you the area of the surface. But there are an infinite number of v's that give you the area, so it's not unique. Okay. One thing that's kind of interesting is that if I had, let's say my curve was maximally visible. What I mean by that is there exists a point or a whole set of points inside this area which can see every single point on the boundary. So I could keep drawing these for every single point. So for now, let's say this is rho of t, and this is rho of t plus dt. And I'll let this be again dl. Then if we go to Wolfram, we say, area of triangle using vectors. Right? Come on. Okay, so we have this formula, which, okay, if we go back, so it's this segment BC here is like our DL, and this AC and AB are like our rho and rho T plus DT. So I'll call this dA. So my dA will be equal to 1/2 the magnitude of rho T cross rho T plus dt. Okay, and we go through and do all this. Which, I guess I'll do now because I can't find it. But we can say that alright, so this is going to be x hat minus y hat. So the rho is x, y, 0. And this is x of t plus dt. I'll just call that x1, y1, 0. So the only term is going to be the z. So we'll have x, y1 minus yx1. Right? And the magnitude will just be the absolute value of this thing. This is bad notation, whatever. Okay, so let me write it out. So 2dA is magnitude of x of t, y of t plus dt minus y of t, x of t plus dt. Now if I divide by dt, is that what I want to do? No, let me hold off on that for a second. But I do want to write these in terms of the derivatives. So I'm going to have x of t times y of t plus dt times y dot plus, terms on the order of dt squared minus y of t times x of t plus dt x dot plus terms on the order of dt squared. Absolute value. So actually now I want to divide by dt. So my x's and y's cancel. And I divide it by dt, so I just get x, y dot plus terms on the order of dt minus yx dot minus terms on the order of dt. So this is all valid when dt goes to 0, so we can neglect these terms. So we'll get dA is equal to 1/2 dt times the absolute value of x y dot minus y x dot. And then the area is 1/2 the integral dt times the absolute value of x y dot minus y x dot. So the reason why I did this okay, but so we're going to have to either, sometimes we might have to multiply by a minus sign. So the area is going to be plus or minus this value, I guess. Okay. So that's the area if you have a maximum invisible perimeter. If, for example, we have something like the letter E, I'm going to say that you're not going to be able to find, I don't know if you can find one, but I'm pretty sure you can't find a point where you can see every point on the boundary. So for example, this little element of area dA, you'll include some of the area on the outside, which you don't want. So in this case, this formula down here will not calculate the area of E. It'll include some area of the outside. Now, I don't know, maybe there's a proof it shows that, no, it's not going to work, I don't think. But the point is that that formula that I just wrote is very similar to this formula up here. So let me actually take this formula and I'm going to write it down here. Okay, so this is a recall. Come on. Oof, this is annoying. So recall this formula. Now my question is, can I make this formula look like that one? So what we need is, we want sinh squared of theta to be equal to minus 1/2, and we want cos squared of theta to equal 1/2. So let's see. Okay. So theta is I pi, or it doesn't, well, I'll write them all down. So I pi n minus I pi over 4. Okay, and do we get the same result for cos? Yes, we do. Okay, perfect. Okay, so A at theta equal to minus I pi over 4. This is equal to 1/2 the integral of dt times xy dot minus y x dot. So there is some correspondence. I think that's pretty much it. I'm not really sure what to make of it. So what it seems to be saying is that if I choose a vector field of alpha and minus 1/2 x, sorry, y, 1/2 x, 0, doesn't matter. Seems what it's saying let's say take some just some crazy curve like that. If I choose this vector, then I guess my area is equal to 1/2. But this doesn't make any sense because I could have chosen another vector. Something special about this vector? It seems like this vector corresponds to a case where my perimeter is totally visible. But the area shouldn't depend on this vector. So the validity, but the validity of this formula for the area depends on the path right? So only a certain well, I don't know. I might do a part 3 of this video where I evaluate this numerically. And analytically and compare. just to see if it's right. Right, you can take some, I'll go back down here, this is a good shape. So what I can do is I can define these boundaries. Select points at random. And check if one of these points is inside this boundary or not. And then the number of points in this boundary should be proportional to the area. Alright, but oh my god.